Good day, students. Welcome to part 4 of the Geometry Regents exam review for January 2014. In this installment, we're going to be going over problems 16 through 20. All right, let's take a look at problem number 16. It says, for which measures of the sides of triangle ABC is the angle B the largest angle of the triangle? All right, so we have a collection of measures here that we're going to use to determine which yields the largest value for angle B. Now, there are a lot of ways that we can solve this problem. Let me show you the quickest way. What you want to do is identify the side length that's opposite angle B. All right, so let me set up my triangle. It's always good to draw a diagram, gives you a visual, and also enables you to label accurately. All right, so let's call this A, B, C. Okay, so we're looking for the biggest value for angle B. So whatever yields the largest value for side AC will automatically yield the biggest value for B. When I say largest value of AC, I mean largest value of AC relative to AB and BC. Okay, so we're comparing this length to the other two. That's what the task is here. All right, so how can we compare? How do we know which AC here is the largest relative to the other two sides? The easiest way to do this is by using ratios. What I'm going to do is I'm going to compare the length of AC in each triangle with the length of with the perimeter of the triangle. Okay, so let's take a look at option number 1. For number 1, AC is equal to 7, and the perimeter is 2 plus 6 plus 7, which equals 15. So the ratio of AC to the entire triangle is basically going to be 7 divided by 15. All right. And in order to get an accurate comparison, it's good for us to express it in decimal form. So 7 over 15 in decimal form, 7 divided by 15 is 0.46 repeating. Okay, so the ratio of AC to the entire triangle is, for option 1, is 0.46 repeating. So whichever ratio gives us the biggest amount, that's going to tell us that AC is very long, as long as in comparison to the rest. Hence, we use the largest value of B. All right. So for option 2, length AC is 8. Remember, we're using AC again because AC is opposite the angle. All right, and then there's a correlation between the length of the side and the angle opposite it. The longer the side, the bigger the angle. The shorter the side, the smaller the angle. All right. So for the triangle in option 2, the perimeter is going to be 6 plus 12 plus 8. All right, 6 plus 12 plus 8, that's 26. So the ratio of AC to the entire triangle is 8 over 26. Let's input that into our calculators and see what we get. 8 divided by 26, 0.307. So we see option 1 is kind of bigger here, 0.31. All right, now let's do option 3. Option 3, AC is 10. The perimeter of that triangle where AC is 10, yeah, we're adding everything here, okay? Remember, AB plus BC plus AC. If you add all those sides, that's what gives us the perimeter, right? So 16 plus 9 plus 10. 16 plus 9 plus 10 is 25 plus 10, which is 35. The ratio of AC to the entire perimeter of a triangle is 10 over 35. Let's see what the decimal approximation of that value is. 10 divided by 35, 0.29. 0.29. It looks like the value of the angle is getting smaller. All right, let's do the last one. 4. AC is 5, and the perimeter of that triangle, where AC is 5, is, what is it? Let's see. Perimeter is 18 plus 14 plus 5, which is, let's see, 37. So your ratio here of AC to the entire perimeter is 5 divided by 35. All right? So let's put that in a calculator and see which one, see what the answer is. 5 divided by 35. Uh-oh, 5 divided by 35. 0.142. 0.14. All right, so 0.14. Okay, so we can clearly see that since, let's write a remark, since option 1 has the highest ratio, angle B is the largest. Okay, is the largest out of the entire bunch. So the answer is option number 1. All right, let's take a look at number 17. Number 17 says, what is the measure of the largest exterior angle that any regular polygon can have? So first of all, what does the word regular mean? Regular means that all sides are what? Equal. Okay? All sides are equal. Now, what's the formula for calculating the exterior angle of a polygon? What is the formula? The answer is number of sides divided by 360. Okay? So exterior angle of a regular polygon is equal to the number of sides divided by 360. Okay? So what is the smallest polygon you can have? The smallest polygon you can have when n is equal to 0, you have nothing. When n is equal to 1, you have a line. All right, for n equals 0, you actually have just a point, no sides. For n equals 1, we have one side length. This is not a polygon, okay? And then when we have n equals 2, what do we have? Two side lengths of equal length, like this. If you just have two sides, this is not a polygon, okay? So we cannot even calculate exterior angles. But we have n equals 3, now you're talking. Okay, n equals 3, you have an enclosed area, enclosed region, and that is in fact a polygon. All right, so let's go ahead and just draw a triangle. All right, if this is a regular polygon, namely a triangle, that means that all these three sides are going to be congruent. Do you know what the exterior angle looks like? The exterior angle is what you get when you simply extend the each segment like this. So that's one exterior angle, that's another exterior angle, and there goes the other exterior angle. So depending on the orientation, if you want to go clockwise, if you're going clockwise, then this would be exterior angles 1. Well, that's actually the exterior angle. So there goes an exterior angle, 1, 2, 3. All right. So the sum of the exterior angles is always 360 regardless of the number of sides of the polygon. All right, so let's make a note here, not a polygon. And then this one also is not a polygon, this is not a polygon, this is a polygon. So to calculate the exterior angles, since the sum of angles of an exterior angles of any polygon is 360, an angle is simply going to be the number of sides divided by 360, okay? So let me revise my formula right here. Exterior angle of a polygon is basically 360 over n, made a mistake, 360 divided by the number of sides. So in this case, we have 360. The number of sides is 3. So when you divide 360 by 3, you're going to have 120 degrees. Now, what happens when you have more sides? What do you think is going to be happening? You have n equals 4, like a square. Let's draw that. So if you have n equals 4, make sure I make it a square. What's the exterior angle going to be? You're going to have 360 divided by 4, and your answer is going to be 90 degrees. What do you think is happening with the measure of the exterior angles here? As the number of sides increase, what you're dividing by keeps getting bigger and bigger. Hence, the exterior angle keeps getting smaller and smaller. It basically approaches 0. Okay, as you can see here, this is 90 degrees, this is 90, this is 90, and that's 90. All right, so as n gets bigger, the exterior angle gets smaller. So what is the largest? The problem says, what is the largest exterior angle of any regular polygon? So the largest exterior angle the regular polygon can have is 120 degrees, and that's a case of a triangle. Okay, if you have a square, you have a regular square, the maximum, the angle is going to be 90 degrees, right? And it keeps getting smaller and smaller. So we can see here that our answer is option number 3. All right, let's take a look at problem 18. It says, as shown in the diagram below, a landscaper uses a cylindrical lawn roller on a lawn. The roller has a radius of 9 inches and a width of 42 inches. So there goes your gardener. Looks like he's running. Anyway, the question says, to the nearest square inch, the area the roller covers in one complete rotation is. So what is one complete rotation of this cylindrical lawn roller? Well, let me give you a visualization to help you see what is actually going on here. So let's say this is the roller for the lawn. If I roll it one complete revolution like that, what just happened? What did we just create? Well, what we're actually doing is we're actually covering an area that's equivalent to the lateral surface area of the cylinder. Okay, and we know what the lateral surface area of the cylinder is. If you consult your reference sheet, you're going to see what the formula is. So the formula for the lateral surface area, we're going to call it L. That's what is provided for you in the reference sheet. We are looking for the lateral area of a right circular cylinder. Okay, so this is a right circular cylinder. All right, so if you look at your reference sheet, the formula is 2 pi RH. And this formula makes sense because if you look at what I just showed you earlier, it's like a rectangle. The width of the rectangle is equivalent to the height of your cylinder, and the height, the width is the height of your cylinder, and then the length of the rectangle is equivalent to the circumference one of the circle on the side. All right, so that's why we have 2 pi RH here. Okay, so let's go ahead and calculate it. We have 2 pi times the radius, which is 9, times the height, which is the length of the radius, which is 42. Okay, so radius with 2 pi RH will help us calculate the surface area. Okay, so let's calculate that. We're going to enter in our calculators. 2 times pi times the radius times the width of the roller, which is the same thing as the height. And then we have all right, let me enter it again. So second function entry, I was supposed to put 42 here, so 42, 2 pi RH, enter. So we have 2,375. All right, so the answer is our lateral area is approximately 2,375 square inches. That's how much area the roller covers in one complete rotation. All right, let's take a look at problem 19. It says in the diagram below, AC and BC are tangents to a circle O at A and B, respectively, from external point C. There's a measure of angle ACB is 38. What is a measure of angle AOB? Now, anytime you see a circle with a tangent line and the tangent and the point of tangency goes to the center of the circle, there is a theorem that should come to your mind immediately. And basically, the theorem tells us that the radius of a circle is perpendicular to the tangent line. All right, so we have a radius right here, and then we have a line tangent to the circle touching that radius. Then that angle formed is always 90 degrees. This angle right here is 90 degrees. All right, so anytime you're thinking about circles, tangent lines, and radii, always remember that at the point of tangency, the radius is perpendicular to the tangent line. Okay? So what does that tell me here? It tells me that this angle here is 90 degrees, and this angle here is 90 degrees also. We're also told that angle ACB is 38, so this angle here is 38 degrees. We're asked to find the measure of angle AOB. This is angle AOB right here. We don't know what it is. Now, this is a quadrilateral. What is the sum of interior angles of a quadrilateral? It's 360, right? The formula is, we talked about this earlier, sides minus 2 times 180 tells you the sum of interior angles of any polygon, okay? So if you have 4 sides, you're going to do 4 minus 2 times 180, which is 2 times 180, which is 360. So think about dollars, okay? If you have $360 in all, you have, this is $90, $90, $38. How do you figure out what's left here? What you do is you add all these three angular measures, and you subtract it from the sum, which is 360 degrees, all right? So let's go ahead and do that. The measure of angle AOB is equal to the sum of all the interior angles of the quadrilateral, which is 360, minus the sum of what we know, which is 90 plus 90. These two 90s are because the radius is touching the tangent line, and that forms a 90-degree angle, plus the 38 that we were provided with in the problem. So we'll just simply calculate what the value is. Let's go ahead and use our calculators to do this. So we have 360 minus 90 plus 90 plus 38. And your final answer is 142. So we can clearly see that our answer is option number 3. All right, let's take a look at the last problem in this installment. Let's write our answer in here. Problem 20. Question 20 is as follows. It says, what is the perimeter of a square whose diagonal is 3 root 2? So what's the perimeter of a square whose diagonal is 3 root 2? Now, anytime you're dealing with a shape that's not provided, and you're carrying out calculations in that shape, one important thing to do is give yourself a visual. Please, please, please do not hold back from drawing diagrams. They really help a lot. Okay, so I'm going to draw myself my nice little square, and I'm going to populate it with the given measure, which is that the diagonal is 3 root 2. So hopefully you know that the diagonal connects two opposite vertices like that. And this right here is 3 root 2. Now let's freeze for a minute. What type of triangle did I create right here? Since this is a square, this side is congruent to this side. This is an isosceles triangle. Not only is it isosceles, it's also a right triangle. What do we know about all isosceles right triangles? They're all similar, right? There's a special relationship with them. The base angles are congruent. This is 45 and 45. How do we know that? Because subtract 90 from 180, divide by 2, you have 45, 45. Do you recall a special triangle that looks like this? It is a special triangle known as the 45, 45, 90 triangle. And that's going to help us solve this problem, all right? So let's go ahead and create our 45, 45, 90 triangle. Let's try it. 1 second. Unfortunately, this isn't provided for you on the reference sheet, so you have to memorize it. Have it memorized. 45, 45, 90 triangle. Opposite the 90 degrees, the longest side is root 2. And then the shorter sides are 1 and 1. Okay? So if you look at these two triangles are similar, okay, which means corresponding size and proportion. So if this is 3 root 2, what do you think the measures of these two sides are going to be? This side corresponds to this side, right? So what happened to the standard 45, 45, 90 triangle to get to this? We multiply the hypotenuse. We scaled it up by a factor of 3 to get the hypotenuse. Now this side is 1 and 1. What do you think we're going to do to this side to scale it up to this if we were scaling it by exactly the same factor? What you do is you scale it up by 3, also multiply by 3, and multiply that by 3. So this special triangle right here tells me that this is 3, and this is 3. Okay? 3, 3, 3, 3, 3. So that's one way you can do it. Another way you can figure out the length of the sides is by using the Pythagorean theorem. Okay? Since you know it's a right triangle, here what you do is you just label them the same variable. So I can call this, let me use blue, I can call this A and call this A. All right, so according to the Pythagorean theorem, I know that A squared plus A squared is equal to 3 root 2 squared. Okay, this involves doing some algebra, if you don't mind. Doing this is much quicker. I just want to show you another way of doing it. So if you work this out, you have 2a squared equals, you square the 3, get 9, and you square the root 2 to get 2. You have 2a squared equals 18. Divide both sides by 2. You have a squared equals 9. Take the square root of both sides, and you have a equals 3. All right? So if you don't remember the 45, 45, 90 special triangles ratio, you can use the Pythagorean theorem when working with squares. Okay, this applies mainly just to squares. So we now know what the side length of our square is. So what are we calculating? Are we calculating the area, perimeter? What are we doing? The problem says what is the perimeter? All right, we know what the perimeter of a square is. Perimeter of a square is 4 times the length of a side. Okay, or side plus side plus side plus side. Whichever way you want to do it is going to be 4 times 3, and your final answer is 12. All right, so we can clearly see that the answer is option number 2. So thanks so much for taking the time to watch this presentation. Do subscribe to our channel if you haven't already done so. And please post a comment to let us know what you think about this clip, and to give us a thumbs up if you liked it. We appreciate it. More clips can be found on mathgotserved.com/testprep.html. Thanks again for watching, and have a wonderful day.